All right, in this quick video this morning, we're going to take a look at a quick review of significant digits that we learned about in class. Significant digits, you remember, apply to measurements. So any kind of measured quantity, you've measured the length of something, the mass of something, or something that you've calculated from measurements. Maybe you've measured the length and width of a table, and then you calculate its area. Every measurement and every calculation involving measurements will have some sort of error involved, and so the number of digits that you put down in your answer has to reflect that. So the digits that you include are referred to as significant digits, the important digits. You've all done calculations on a calculator where you end up seeing 10 or 12 digits on the calculator screen, and you wonder, how should I round off my answer? Well, the answer involves understanding significant digits. So the rules for counting which digits in a measurement or answer are significant are pretty simple. There's 4 of them. We talked about this in class. You remember that any non-zero digit in a measurement is considered significant. So any digit like a 1, a 2, a 3, all the way up to 9 will always be considered significant. Zeros are the digits that are a little bit confusing. When you have rule number 2 here, when you have leading zeros, so zeros at the beginning of an answer or a measurement, they're never considered to be significant. They're simply placeholders. There's no non-zero digit to go there, so we have to put a 0 in its place. So for example, in this number 0.002 grams, that measurement, all of these zeros at the beginning are considered leading zeros. They're starting the number, so they're not considered to be significant. So I put X's above them. The number 2 is a non-zero digit, so that one is significant. So that measurement has just one significant digit. Rule number 3 says that if you see a 0 in between non-zero digits, that 0 will always be significant. So look at the example that's shown there. 0.002001 seconds, and we already know that the zeros at the beginning are not considered to be significant because they're leading zeros. Then we see a 2, so that's a non-zero digit, and a 1 at the end, that's a non-zero digit, and then there's 2 zeros in between them. So according to this rule, the zeros that are in between non-zero digits will count. So that number has 4 significant digits in it. Where zeros get really tricky are when they are at the end of a measurement, when they're trailing zeros. Now, there's one school of thought says that if you see a decimal place in the number, in the measurement, then any zeros at the end, the trailing zeros, will count as significant digits. So for example, in this number 0.0200, I can see a decimal, that little 0 point, I can see a decimal. So we already know the zeros at the beginning don't count. The 2 is a non-zero digit, it counts. These zeros at the end, because I can see a decimal, this rule, this school of thought says you should include those, they get counted. So that would have 3 significant digits. If you see a number like 20 liters with a decimal at the end, 20 with a decimal showing, then that 2 is considered significant, and the 0 at the end, because I can see a decimal, is also considered significant. So this school of thought says when there's a decimal visible, the zeros that are trailing at the end will always count. And that rule says if there is no decimal showing, then those zeros at the end would not count. So for example, if you see a whole number like 5,000 liters, but there's no decimal showing at the end, then only the 5 would count, and these zeros would not count because there's no decimal place showing. But if somebody had written 5,000 with a decimal showing, then now all of those would count. The zeros would be trailing with a decimal showing, and they would count. Now that school of thought really only has 2 possible results. All of the zeros count when the decimal's showing, or none of the zeros count if the decimal's not showing. Sometimes you want something in between. You don't want just an all or nothing. So the best thing to do is to switch these numbers to scientific notation. So for example, consider the 5,000 liters. If you meant only the 5 should be significant, then you could write it as 5 times 10 to the 3, scientific notation. The times 10 to the 3 is not considered significant. Only the 5 there would be significant, so that would have one significant digit, only the 5. If you wanted to show the 5 with one of the zeros to be significant, so you wanted two significant digits, then you could write 5.0 times 10 to the 3. Again, the times 10 to the 3 is not significant. Now this 0 counts because I can see the decimal 5.0, so this would have two significant digits. If you meant the 5 and the two zeros, you would write 5.00 times 10 to the 3, and now that has three significant digits. And if you meant all of the zeros to be significant, you could write 5.000 times 10 to the 3. So you notice there, because we've switched to scientific notation, we can now say whether there's 1, 2, 3, or 4 significant digits, instead of just an all or nothing, 4 or 0. All right, let's take a look at some examples here. I'm not going to do all of these, but can you count the number of significant digits in these different measurements? So I'll highlight the few of them that we can do together. All right, how about, well, let's do one more. How about this guy here? So how many significant digits do you see in these measurements? Pause the video and try it, or if you've already done this, check your answers. So the first one there, the one I've highlighted, the zeros at the beginning are leading zeros, so they don't count. Only the 1 and the 7 would count, so that has two significant digits. The second number that I highlighted, number 4, has scientific notation. We know the times 10 to the minus 3 part of that is not considered significant, so we just look at the 2.90. The 2 and the 9 definitely count. The 0 is at the end, and I see a decimal, so that means it counts. There's going to be three significant digits, 2.90. Question 6, a whole number. I don't see a decimal at the end, so we'll follow that convention that says if there's no decimal visible, the zeros at the end do not count. So therefore, this has only two significant digits, the 7 and the 5. Number 7, scientific notation again. Times 10 to the 4 will not count. 8.0, the 0 there is trailing, but it has a decimal point visible, so it would count. That has two significant digits. 4,000, number 9, there's a decimal showing. So that means all of those zeros count, using that rule we talked about. The 4 also counts, so that has four significant digits. And number 14, the times 10 to the 15, scientific notation does not count. 6.020, the 6 counts, the 2 counts, the 0 in between those counts, and the 0 at the end, because the decimal is showing, it also counts. So that has four significant digits. Number 17, the 5 and the 2 count. The 0 in the middle of non-zero digits counts. The 0 at the end, there's no decimal visible, so therefore that 0 does not count. This would have only three significant digits. All right, so that's your counting significant digits. If you can't do this, it's hard to do anything else. So if you're having trouble here, you want to ask for some help. Now, sometimes you've done a calculation, and your calculator shows a whole bunch of numbers on the screen, and you have to round off your answer to a certain number of significant digits. So here we have an example. Let's take a look at number 3, number 5, and maybe number 8. We'll do these three. You have to round off to the digits that are shown here. So in number 3, we have to round this off to 4 significant digits. So if we're rounding off to 4 digits, we're going to keep the 1, we're going to keep the 7, we're going to keep the 3, And we have to keep just one zero. That would be 4 digits. But how do I write 17,300 and show that only that first zero is significant? There's no way to do that unless you switch this number to scientific notation. So let's write it in scientific notation. We'll move this decimal over 1, 2, 3, 4 spaces to get a number 1.73, which is between 1 and 10. So because I moved it 4 spaces, it'll be times 10 to the 4. And 1.73 would have 3 significant digits. To get our fourth digit, we include that first zero. So 1.730 times 10 to the 4 would have 4 significant digits. Question 5, we need 1 significant digit, and the answer is on the calculator is 60.07, etc. So only the 6 can be kept. Now here you have 2 choices. You could write that as 60 without a decimal place. Now the 6 will count and the 0 does not count, so that has 1 significant digit. Or we could switch this to scientific notation, and we could keep the 6 times 10 to the power of, and to get a number between 1 and 10, we had to move the decimal 1 place, so times 10 to the 1. So 60 without a decimal, or 6 times 10 to the 1. Number 8, we need 3 significant digits. The times 10 to the 26 does not count, so we can already keep that, times 10 to the 26. And then we need 3 digits, so we'll keep the 5, and we'll keep the first 2 zeros. But look at the next digit, it's a 2. Because it's a 2, we're going to leave that 0 alone. If it had been something like a 5, a 6, a 7, an 8, this digit here, then we'd have to round from 5.00 to 5.01. So you do have to look at the next digit to see whether or not you need to round up your last digit you're going to keep. So here, because the next digit is a 2, we don't have to round up, so we'll just leave that as 5.00 times 10 to the 26. All right, let's do one more of these guys. How about number 10? So we have to keep 2 significant digits. All of those zeros at the beginning will not count. There's the 0 at the very beginning of the number, the 4 zeros after the decimal, all of those leading zeros do not count. So now we need to keep 2 more digits. So we'll keep the 6, and then comes a 0. So do we write 60? Those are our 2 digits. Well, after the 0 comes a 7. So based on what we set up above, instead of 60, you'd have to round up the 0 and call it 61. So 0.000061 would have 2 significant digits. If you wanted to put that in scientific notation, 6.1 times 10 to the power of, and we had to move the decimal 1, 2, 3, 4, 5 places. We'll put a 5. But that number, 0.000061, is less than 1. It's a very small number, so the exponent here is going to be a negative 5. Right? In scientific notation, numbers that are small like that have negative exponents. Now, calculations with significant digits, our last topic. We learned, we're going to do another one after this, but we learned in class, in our first class, that if you add measurements together, in this example, adding or subtracting, there's a rule that says when you're putting your answer down, you have to look at the number of decimal places that were in the measurements being added or subtracted. So for example, look at part A. In the numbers that are being added here, these are all measurements, the first number, 12, has no decimal places. It's just 12. 3.1 has 1 decimal place, the 0.1. 79.71 has 2 decimal places, the 0.71. So that guy's got 2 decimal places. The rule for adding or subtracting is to go ahead and do it on your calculator. So I'm going to grab my calculator and go 12 plus 3.1 plus 79.71. So my calculator says that the answer is 94.81. But the rule for adding or subtracting is to round off the answer so it has the least number of decimal places that were in the measurements being added. So because 12 had no decimal places in it, we have to round this off to have no decimal places. So we look at the 94, then there's a 0.8, so we'll have to round that up, and we'll call it 95 centimeters. All right, we'll do another one here, our part C. So go ahead and add the numbers on your calculator. 2.419 plus 3.91 plus 7.0518. So my calculator says the answer is 13.3808. That's what the calculator display shows. But when I look at the measurements that I added, the first one has 3 decimal places, the second one has 2 decimal places, the third one had 4 decimal places. So in the answer, we can only keep 2 decimal places, the smallest number of those choices. So 13.3808, we're going to have to round that off to 13.38. There's 2 decimal places, grams. All right. Now on this little question, I told you to omit question H and J with scientific notation in them. We won't be worrying about that. Now the rules don't only apply to adding, they also apply to subtracting. So for example, take a look at choice M on here. You grab your calculator and you subtract those volumes, 145.63 milliliters, take away 28.9 milliliters. My calculator tells me that the answer should be 116.73 milliliters, but in adding or subtracting, we're going to round off based on the number of decimal places. So this guy had 2 decimals, this guy has only 1 decimal, so we can keep only 1 decimal. So instead of 116.73, we call it 116.7 milliliters. All right, so there's hopefully a review for you, or you've checked some of your answers to see if you're understanding it. If you find yourself not understanding it, you see some mistakes you're making, you really don't understand my explanation, then let me know through Google Classroom, or let Ms. Watts know through Google Classroom, and make an appointment and come in and talk to us about it. This is a topic that we're going to use all through our course, so be sure you understand it. Every time we do a calculation, we're going to be rounding off answers using these significant digit rules. Now here we've looked at just adding and subtracting. Our next discussion in class will be looking at multiplying and dividing as well. All right, so there's more to come with significant digits.